The first traditional way of doing all these things before even coming here is on using asserts. Asserts is like, one way which we are doing already. If I take an example of asserts, how we do the asserts, if I can take on.
By writing assert.
Yes. So assert has a simple syntax. When we have worked on the exception handling, we discussed about the asserts. Assert is a keyword, and after that we need to give a statement. So whether it will be successful or not, it will take care. If it is successful, everything would be good. If not, it will throw in error. So how to handle that? So like this. If I write like a assert 2 plus 3, assert 2 plus 3 equal to 5. Means what you are telling that, hey, 2 plus 3 should be equal to 5. So why we need to go for assert first of all? Can't you test like this? So 2 plus 3 is equal to 5. You can test, right? So what is the difference between these two approaches? In both the approaches, you will get the same answer. But the way things works is slightly different. What is the point is like, if I go to this directory, Python a so and so. You see, in the first example will result a print statement called as true or false, whereas second one will not do like that. So in which case, okay, if you have a program, if you are in a development mode, then you can check whether what is a true or false. Say your code was gone to already production, or like it is about to go to production, or like if you have like so 1500 or 10 or some very big number of statements. For everything you cannot go and check whether true or not in the output, and then you cannot manually do. If something is an issue, it should fail immediately. So for that only, so we can write in a different way. Say you are doing like this, you write like a one more thing. The same 2 plus 3 can also be written like this, comma, hey, 2 plus 3 is not resulting in to 5. Like that you can write. Means assert, along with that it will take one more statement. But sir, it is not executing. Yes, it won't execute. If everything is good, means what are the condition you told? If it is returning a boolean true, then it will not do anything. Say like if I go ahead, if I say like assert same 2 plus 3 plus 3, say if I say like equal to 6 I do. And if I do the same statement here, you see, now if I say is not equal to 6 I wrote. As that statement is not correct, it is throwing an error. Whereas if you do the same thing with it, if print statement, then what will happen? Print statement will just print the value, whether the result is true or false. If there are 10 trues and false, every time you will not go and check which one is false, which one is true. It's very hard for you. That's the reason these asserts will come to picture. Okay, sir, these asserts are good. So how do you handle it? Maybe like try except, you write an assertion error and you print it. Or so if the code was broken, you can handle. So you writing the asserts every time. So you doing everything on your own. You need to do. Say like if I have one more condition like, hey, 10 minus 34 is greater than 3. It should be equal to minus 24, which is less than 3. If it is no, so it will handle that. And similarly, I have one more state. So wherever I have a use case, I need to specify like this. So I should be very careful in terms of what I am doing. And also, right? So if I give any statement, say, if I say like one equal to true, yes, if it is correct, it will not do anything. Whereas if I say one is equal to one as a string, yeah, so if I say do like one is equal to one as a string, so like that I can give anything. is operator or whatever. What is saying? Hey, 1 as a string is not equal to true as a string, right? That you know. So if I say not equal to, then it will say true. So this is how it actually works. Hope it's clear now. So what is the purpose of these asserts means? For everything we need to have an assert. Before even going for the unit testing, I will tell you the real practical problems that user faces if there is no unit testing module or on a separate module for it. If let's say I am having a function which is returning some values, say I am taking one result like this. You see here. So it is taking any values, two values, and returning these things. And let's do the typing for it. Hope you remember the typing, right? Let's do that to make a note of everything. Integer. The second one is also an integer. And what is that you are taking? If you are taking the values like integers, and you get like floats, right? But like so though like typing will ensure like you are passing exact values and doing like this, but it can work with areas. So how do I address this problem? If I need to make a call and get the result, so how I do? If I execute like if underscore underscore name underscore equal to underscore main underscore, I do it. You see now, I made a call and I'm executing and getting the result. This is how traditionally you execute any program. But at the same time, every time when you're doing, you want to check whether particular condition is correct or not. Means code reliability. If you want more reliability on the code, you need to have the checks, right? Validations and checks. Either you can do directly like this and say what I'm trying to say, hey, the result should be equal to 30, I'm saying. Either I can go like this or I can do like this. Result is equal to. Anyhow, result is coming like that, right? I can assign like this also. Incorrect result, something I wrote. You see now, the first one is returning a true for you, saying like it is correct, what are you told. Second one didn't throw any exception. It itself means that so and so. So that's the reason most of the time in real time we should not place exception, try exceptions for the asserts. If you place try exceptions, there is no point of even writing an assert, right? So this is not a practical purpose. So, but like if you see in your code, we should write like this and say if I want to touch on these things, if I want to pass all these four data types, like integers, I want to pass int and float, floats and integer, like this, I want to pass any of them. And if you remember, I told if you want to pass any of them, how to do? If you have two data types, how to pass?
Any
Or like any data type?
Union.
Union. So if I do like union, I can pass two things, right? If I pass like union, so union of, or like directly. So for union operator, we have like this. Like this, you can pass. So here also, so we can take like this. There are these things, and you want to do. So technically, it will not solve any problem. So even if you do mypay also, it will give the same answer. But subsequently, I want to execute further results. Means not only integers and floats. I want to take like strings also. If one of them are strings, even then I want to go to execute. In that case, what? I took like int, float, string, right? Any of these three I want to get. Int, float, or string. So, or like, float, whatever may be. So I can take like a, alias type and I can assign, right? Assign to it and I can do whatever I want. But like whatever I get, I want to get the result as well. And similarly, I want to check everything. And similarly, if I go for one of the edge cases, if I check, I'll understand. Addition of, so at this value, string and a boolean. If I give, in that case, it is throwing an error that, hey, I will get an incorrect result. The result is not correct. But somehow you have implemented. So like this. Instead of directly doing, you did indirectly. But you understood, right? Too much of asserts are there. Now tell me in this entire code, how much is the actual useful code? Useful code is like 1 2 lines only. This is all testing only, right? This is all not the business code, right? Not actual the business, but you are adding all these things. So those things we need to change. That's the reason like people need unit testing or some framework. Let me tell you one more example. If I take like this example, you can notice that I am taking name any data type I can take and I want to do. So you see here, what are the data type you are doing, and I'm checking the result. So generally is equal to none, so and so I'm doing. So like that. So this is actually resulting in a none. So that's just why I want to verify that it is doing the same. Or like if you go for one more example, the same thing, for every example where am I executing, what I'm trying to show you for you is that how much is the actual code, how much is your unit testing, or like any testing. So the actual coding is like 2-3 lines only. Your testings are very big, right? But do you think like real in program they need all these things in production? They don't need, right? In production they expect you to write the best code. That's it. How you have written, it's up to you. So now based upon these things, if I can go through, so B unit test module. If I can go to this in the unit test, I can go with the next thing, that how I have addressed these problems with a unit test. If I can, okay, in unit test, how to address this problem. Let me tell you in the first set of use cases, like step by step we will go by each of the use cases, and I will explain you how things works. This unit test I can explain even in a Jupyter notebook also, but I just better want to show here so that you will understand and remember the content. Okay. If I go for like um, instead of this, a example. So one of the folders I want to do, and in that if I say the first one, okay, you see here. First, there is a module called as unit test. If you can see that, there is a module called as unit test. If I ask, hey, what are the DAR of this unit test? And if I navigate there, you can see that the list of attributes. When we did the DAR, you got these many attributes are there. Means with unit test, we can do these many things. At the same time, if I ask help of this unit test, you will notice the humongous amount of help that it has. It's a unit test module, so it has like basic attributes. What they're saying, this is a simple test that how you want to do. A simple test of how you want to add some things and how to do the multiplication and so on. I will explain, don't worry. I'll explain like how things works, what are the events. They gave like everything. What are the classes, built-in classes they have. So function test case. So like that they have many things. Okay, let's start working on this unit test. I want to test like very simple things. Okay, say I want to test. Generally, if you are want to add two numbers, you want to check the result, right? You remember we did first one, 2 plus 3 is equal to 5, right? This is what we checked. Even traditionally using this one also, you did like 2 plus 3 is equal to 5. Maybe if you want the output also, you can do like in a smarter way by placing within it, such that you will see the output also what are you doing. This is how we did till now. If I need to do the same thing, say class, we need to write a class. Okay, so test addition. Addition is the one we need to test, right? We need to do. and we need to like inheritance unit test dot test case. This is how we need to inherit. And what I want to test addition only, right? So test, so you can write like test addition positive case. I just want to test something. What are you want to test? You just tell that it. You you take two values and you want to check the result. So what you have self dot. So there is something called as assert. Assert equal of 2 plus 3 comma 5. So it means like indirectly you are telling that hey, assert equal. Here you are doing an assert equal to, right? You are checking the equal check. This side and that side should be equal. For that there is a command called as assert equal. If you use that, you can directly do it. Now how do you execute this code? If I say like in Python space example, see it is executing the first statement. Here it is showing like true. Second one is true. That's the reason it didn't throw any error. And did it execute? No. Then how to execute? There are two ways of executing any unit test. Within the program also you can execute. So within the program, I told right, same like in the earlier doc test and MyPy also, like this here also. If I do unit test dot main, I can give the verbosity, means how much level of information you want. So verbosity 2, verbosity 3, like that, means levels. If I say no verbosity, you just get an exception. If there is an exception, you don't get like more details. So if I do this verbosity and action, did you see now what is saying compared to the previous one? So the first statement, because of this only you got, next fine. From then onwards it executed. What is saying? Test addition positive. Did you see it executed? So, and here it is part of this test addition and unit testing. So that is how it works. And in the same fashion, I can add one more test. Say like this time I want to test something else. Say like I want to take two variables. Say like choice 1 is equal to true. Choice 2 is equal to say false. I want to check whether both are equal or not equal. Say this time I want to check like choice 1 is not equal to choice 2. So this is what I don't want to do again the print statement, just for you to understand. Now if I want to implement class, write anything, test test check or something, you write. So unit test dot test case. So define test something, test booleans. I wrote something. So so simple, a class with a method, there you do these things. And I do this choice 1 and choice 1 is equal to choice 1 is equal to true, choice 2 is equal to false. Now what I do, instead of assert, so what I do, I want to check the equality, right, or not equal. Assert not equal. Simple, whatever you wrote, I am doing the same thing. Choice 1 is not equal to choice 2. That's what you want to tell. And if I execute right now, did you see what happens? It will execute now two tests. You know what happened? Did you see that ran two test cases in this much time? Okay, means everything is correct, successful. What if you do the something else? So means like if I say instead of choice 2, I write one more statement. So I'm comparing instead of two values, I am checking with the first one only. Or like I'm checking with a real true. I'm checking. Choice 1 is true, right? So this one I'm checking. I'm telling that choice 1 is equal to true. It is wrong, right? So what to say? Hey, I executed two tests. How many failed? One of them failed. Which one failed? So test booleans was failed. Test booleans means it's not giving the class names. It is giving the method names, right? Test boolean is a test case which was failed. So in that there were two asserts. It doesn't mean that we should not have two asserts. We can have any number of asserts. Say choice 1 is there. I want to check it is a false. Choice 2 is there. So choice 1 is there, which is a true, right? So it is not equal to false arrow. And similarly, choice 2 is there. Choice 2 is a false. So I will write like it is not equal to true. So it is up to us, like how we want to do. And if I want to do multiple things, so if I say choice equal to, if I say choice 2 is equal to false, right? So I can do the same thing. Choice 2 is equal to false. If I can do multiple statements also. If everything is correct, for every correct one, you will get a okay. If there is a mistake, it will get a fail, and you will get the fail statement. Hope you understood what I'm trying to say. And it doesn't mean that we should write everything individually. So you can do the same checks in the same place only. Say like I want to test two strings. I want to check. In the same things, I want to do two strings check. Maybe like I take this time self dot assert. Assert is the most important thing. Self dot assert say equal of two strings I do. Empty string and empty string both are equal. Empty string is not equal to the other thing, right? Not equal to the string with the white space. And also hyphen and also like this these symbols, these are not equal, right? So these two are not equal. So like that I am doing some real use cases, or like I can say that Uday is not equal to Uday, right? So what's the difference? Both are not same case, right? Like that I wrote all the test cases. Now in this case, how many test cases it will think? So it's not like how many asserts you have, how many methods you have defined. In this first class, one method is there. In the second class, there were two methods. So that's why it will take like there are three test cases. You can have any number of asserts, but only the methods will be counted. Hope it's clear what I'm trying to say. How I did it, right? You understood now? Now, going ahead. So now you understood how to do everything individually, right? Let me do like one good example in understanding these things further. Say, as I told, so unit testing can be done with these things, right? Any of these things. One thing we need to understand in the unit testing is about the test cases that we generate will go in an alphabetical order. Means like you can have multiple test cases, I told, but you need to understand one point that they will do in alphabetical order. If you can observe carefully, I wrote like test booleans and also test two strings. Which one executed? As a test addition and test string are there, check are there. Test addition A is coming first, and test check C is coming next. That's the reason they came. So if I place them in the other order also, they will execute in the same way. That's what I want to prove. And see, coming back to where we have started. Yeah. So let's say I have the same function which we have done earlier, which is
Okay.
like taking two inputs.
Hello.
Yes, please.
Yeah. So I just want to ask that the all the test cases will be executed in alphabetical order, right? So it is depend upon it will check first the class name alphabetical order or only the test cases.
So both. So let me take the same example then in that case for you to understand. I took these examples, right? So I am telling that they execute in alphabetical order. Instead of this example, let's take the same. So I taken this example down and I'm placing it down. Okay. So test, there are two types of tests now. And in this also, I'm making this one in the top, followed by the other one. Now, did you understand? So test boolean is alphabetically first, right? And test toStrings will come next. Similarly, test checks C, test addition. So A will come first, right? Now, if I execute Python, A so and so. Did you understand now what will happen? So which one executed first?
Taste addition positive.
So why addition? Because
Okay.
it will take these three individually. It will check like what are test cases you have.
Okay. Okay.
If you in that check like first it will take all of them together. Okay, come on, give me all the test cases it will take. In those it will do the alphabetical arranging. Okay, I got three. Then which one will happen? So alphanumeric. Alphanumeric order means first this one, then the test booleans will come. So then the last one, test toStrings. Okay. So that's the reason you can see like addition first, then boolean, then like toStrings. Hope it's
Okay.
clear.
Yes.
So this is what I mean to say like alphabetical order. Next, going with like one more example for you to understand. Mm, Okay. So let me take one example this time. Say again, I'm doing like import unit test and I'm doing this addition. So I want to test the unit test, how these things are working. How to test? So whenever I'm doing a class test, every class, unit testing class should prepend with a test. Sir, what if it is not prepending? Let me show you that also. Say I'm doing like test addition. So we need to inherit unit test dot test case. After inheriting, so we need to write the test cases. Say test. You know that, so it will go in alphabetical order, right? So in this particular order, sometimes certain things you want to execute first, right? And certain things afterwards. In that case, you can write like test 01, test 02. So the class should start with a test, T capital. So method should start with a test, small letters. Which is like the minimum condition. And the file name also, in fact, should start or end with a test. But at this moment, we are not going there. But so this is how we work. Maybe write like, I will write a condition that A, so test one positive, I wrote. And within that, instead of doing anything, I'm doing like a small print statement. Okay. So now, how do you execute this code? I told that in interactive mode, you can, so script itself, you can do like this. So if you can directly execute the program. If I execute the program directly, you can notice that it is executing. Okay, now let's see the case. If I remove this, test in the starting, is it executing? Still it is recognizing. So even if you write an ordinary thing, as you have inherited this one, it is automatically calling when you do this one. And if say that instead of test, I say like, my test, I prepared with my, what it is saying? Zero tests. Okay. Even if I remove the my right now, in that case, it is recognizing one. Now, did you understand? It is not mandatory for like the class name, but like for the method name, it should mandatory to have a test prepending. But as a best practice, they write even a test for even the class also. Hope you understood. So now, if I want to do the testing, what all things I can do, I will route. Say like I want to do the positive test. So instead of doing like an ordinary assert statements, no more it's needed. Because like, if assert is wrong, what will happen here? What if I added both the things? Ordinary assert statement I gave, like this also I gave. Then what will happen? It tries to execute. If everything is good, good. If there is an issue, that's where you'll understand. Okay, assume that there is a problem. Okay. If there is a problem, generally, assert is a problem, what will happen? Your code will be broken. Did you see? The code was broken, right? Assume that, so, or like, so here the problem is instead of 30, I wrote 34. Means if your code has an issue, so it will say like this. If you have an assert statement, it would be a difficult. That's the reason, like, it's better to go with the assert statements rather than going for an ordinary asserts. That's why, like, in any code, when you're going for lintings, the static code analysis, if there is any, assert statement, it will warn us, hey, you are having an assert. When you're pushing to code, be careful, like that. So like that, we can add like anything. Say under that addition positive means I want to give the positive test. This is also called as like a happy testing, right? So if you in happy testing, this is kind of like a testing strategy, giving the known values and expecting the result, everything positive. Positive testing is also called as happy testing. This is one convention for you to understand. Similarly for the addition, so I want to do one more use case. This time I want to say like addition of other data types. Multiple data types I give, I want to do. But did you see the test names are not same? I wrote test 01, test 02. So now doesn't matter like what are the variables you are starting with in the test. So it will go in this order only. Even if I place them in the different order also, they will execute in this way. See, if I take this one and place down, you see now, if I execute, see test 01 came first, next test 02. So no matter how you have defined, they will execute in this order only. Hope it's clear. Next, after this, you can also add testings like, uh, one more test case. Let's say I have added one more test case. So now totally we have three test cases. Three test cases were added. And if I add like one more test case, so I can add on like this, different test cases, positive, positive, negative, so critical, like that, all use cases you can do. So the more you do, the more you will understand. And
But
like,
sorry.
please
Yeah,
go ahead.
I have one question. The line number 20.
Mhm.
So there is a 20 is a string, right? So it will not throw an error, any error.
No, because like here, so both are like integers, right? We are
Oh,
converting to float, so it will work.
okay, okay,
If you, yeah, we are not just directly adding.
okay. Yeah.
So that is how it works. Next, going further, for the same example, I can do a slight difference. Means like skipping test cases. What do you mean by skipping test cases? If I take this example as it is, and I go ahead and do this, I have these test cases. Now this is a new code, Python, C so and so. Did you see that how many test cases are there? Four test cases. How many asserts are there? Assert equal, assert not equal. There are many things like that. Though you have n number of assert statements, how many methods you have defined, that will tell you like how many you have. And if you want to skip something, either intentionally or for like some purpose you want to skip, or like you want to skip till something was happened in another way, all those things you can do. Means let's say I want to skip the third test case here. If I want to skip, I can write like this: unit test dot skip, and you give me the reason. Then whenever you are executing, see, earlier it executed all the things. Now if I execute, it says that hey, it ran 4 tests. Okay, means everything is good, but one of them is skipped. So which one is skipped? Did you see the test 03? Test 03 is missing here. In the same fashion, test 04 also I want to skip. How do I skip? Another method for skipping. If I do like this, did you see that it is not reaching, code is not reachable because it will stop there. If I execute right now, only 2 test cases were executing and 2 were skipped. Is it clear? So like that, you can intentionally skip certain tests.
Sorry, why 4 was skipping?
Because I wrote a skip. Skipping, either you can write as a decorator or within the code also you can write like skip test.
Oh, skip test. Okay, okay, got it.
And skip test, so you can do with like a condition also. Okay, so maybe like conditional skipping. So conditional skipping, it is more useful whenever you want to do a conditional skipping. Maybe like, if 2 is less than 3, then you want to skip. If I do like this, then what will happen? Of course, that condition is every time true, right? Maybe like in winter, I want to skip certain things. So I need not check certain things in a particular way. This is kind of like a conditional skipping. Conditional skipping. So, and also like, um, there are like multiple kinds of skips like this. Skip is there, skip level is there, skip until is there. Like the different examples you can do. Maybe like one more example for you to understand. Um so I have this time example with a simple hello world. I want to test it. Sir, what is that you want to test here? Yes. Can we test something here now? So here you wrote a function and you are not returning anything. How do you test it? So in this case, to test it, I can say like class test hello. So this is how you need to remember the minimum things, right? Test case. So first, yeah, if you see here, hello world is there. This function is taking no arguments and this function is returning nothing. So what all we can test? That it is printing a hello and it is not returning anything. So first like test 01, say returns none. Hello self. What I can do? Simply what I can do, hello function uh, equal to none if I do. Generally, the result whenever you're comparing with equal to, so they say like, is, they say. So instead of directly doing equal to, they prefer us to go with a is. So means like you can do in 2 ways. Is like that they say. So, but both the things we can implement. How do you implement both of them? So if you want to equal, so test equal hello result equal check equal check. You can write anything you want. And in the same fashion, you want to do like test 02 hello result. So object means identity check. So like that I wrote. So you have two statements, right? How do I implement that? Self dot assert here equal to. So this is, there are many things are there, equal, equals, equal, not equal, is false, like that I said. So I do like hello and like equal to none. And the same thing we can also do in another way. There is, yeah, I'll tell you that also shortly. Self dot assert is e- assert is none of. Did you see now? So if something you want to check with a none, so you have one attribute called as assert is none. You can directly also check with that. If I do that, so it will execute. And if I execute, say like Python d so and so skipping unit test, if I execute, I got the answer. How many test cases were executed? Two test cases. How many times print happened? Because everything is printing, right? So that's why those many prints you got. Similarly, you want to do a negative test. Say like I want to tell like I want to do a negative test. If I say negative, assert is not none, I'm saying. Hello, when it is calling, the result is not none, I'm saying. If I do not none, obviously it will throw an error because it is correctly throwing an error, right? None. So you can do that check. If I want to implement like not none, I can do that. So, and if I want to skip this kind of things, so we can do it. So skip means like for temporarily you want to avoid, or let's say some functionality someone need to do. Till then you want to not test that. Like that in all the use cases you can go ahead. Hope it's fine till now. So after that, like, so if I go ahead, if I see next thing, what I will go, yeah. If I go for like one more good test case, if I say like D happened, E example. In this case, I want to take a unit test with some values and I want to do the operations on those two values. So till now you are doing any local operations, but you are not doing on the same jobs on multiple things. Let's say I define two class variables and I want to do the additions or subtractions. I want to do the checks. Then see, I wrote like the first unit test, test 01 addition. I'm writing one docstring about that. So here I'm taking those two values. I told class level variables you can access within the instances also. But whatever the changes you make will not get affected there. But you can just use it. So I'm using this one. Means I'll get 50 and 40. If I add both of them, I'll get result is 90. I'm checking that. And similarly, if I do like this one more test case, say test 2 subtraction. On the same numbers I want to do. So self dot number 1 minus self dot number 2. So both the things I am doing, it is checking. Till now, what I am doing, assert equal to is the only thing I told. You give one value, the other value, it will check both are equal or not. If you want to do any conditions, say tomorrow you want to do not equal to, or like multiple conditions you want to check. In that case, you have something called as assert true. If say some things will be very difficult, you cannot test them directly. Say assert true, I'm doing. So what if I do like, 2 is less than 3 is less than 4 is less than 5 is less than 6 is less than 7. If you want to implement this kind of logic, so can you do that? You need to write like multiple assert into assert into assert into assert. It was like really crazily big, right? So then in those cases, you write like this. So that is the beauty of this assert true. It can help you in all these cases. So, and similarly, you want to do some kind of division check you want to do. See, on the same numbers, I want to do division also. I take two numbers and I'm getting the result. And you remember, whenever you're doing a division, you may not exactly get the same value, right? So if I'm doing two division, like I may not get the exact value. Some decimals it may change, right? So if you want to tolerate that, you say almost equal. So means some kind of tolerance also it can bear. And similarly, so there is one more thing, like after addition, subtraction, multiplication. I have multiplication also I have. Totally 4 types of things I have. Now, if I execute this one, I'll get it. See, if I execute, I get these 4 test cases. Python, E, right? E, if I execute. So this is also skipping unit tests. Before even going there, you can see that. What are all the results I got? Did you observe carefully? So how many failures are there? First one, if you see, subtraction was failed. So subtraction failed. Then like division failed. Then so and so. Why they executed in a particular order? Because they gave a number. So what it is saying, hey, 10 is not equal to minus 10. Here I am getting a 10 and not equal to minus 10. If you observe carefully, it is telling here only. Line 21, I have a problem. If I go line 21, this is the line which is creating the problem. So what it is saying, result is not equal to minus 10. Means it doesn't mean that the remaining are correct. So it doesn't mean that. Within this test case, the first one itself is failed. That's why it didn't execute the remaining. Whether they can be wrong, this is also wrong, right? In fact, but it didn't execute. It will fail at the first things. But the code will not be broken. It will skip that and go to the next one. Go to the next case, like that. So now I understood that it is failed. Now I want to do the condition that, hey, skip this. Until now, we are just doing a skipping, but we didn't write a condition, right? If you want to do a conditional skipping, how I wrote here? You remember in the previous case, I wrote condition like this, right? So outside skipping like this, within condition, if you want to write smartly, you can do that. But here, if you see, if I want to skip for a particular things, you see what I did? Skip if. This is another kind of thing. Skip if means if this condition is satisfied, then skip that. The same thing which I wrote earlier. Number 1 is greater than number 2. In that case, skip this routine. I'm just doing like this. CLS and so and so. Did you see what happened now? Test 02 didn't execute. It is saying skipped 1, right? So as number 1 is greater than number 2, it skipped it. So what if I have like, say 5.0? Did you see that? It executed the second case also. Of course, I am removing this. Now it will execute and give me the result. So this one is skipped. And similarly, I have this division. Now division is also good. So division is something interesting. It is saying like false is not equal to true. The result value is true is equal to so and so. I'm checking, and this one is failed. So maybe like, this is not equal to. Equal to you can do check, but almost equal to you cannot check, right? In an ordinary thing. So that's what you don't have a perfect way of doing these things. Equal to checks in our ordinary things. But that's the reason almost equal to comes to be very handy for us. So it will execute fine. And also for this also, for division also, I can do one more thing. For this also I can do. Here I do skip if. Means if this condition is satisfied, it will skip. So at the same time, here I'm saying skip unless. Means unless this condition is true, execute in all the cases. Now if I execute again, in this case also it will execute. And see there, skip unless number 2 is equal to 0. So if the number 2, it becomes like 0, only in that case, it will execute. You see, it has gone inside and you got it right. Just I'm trying to show you the things, how it works and like that. And similarly, so you have like some of the test cases to be failed every time. So in that case, I can specifically mention like expected failure. Observe carefully. I'm saying like expected failure. This result will every time will be failure. I was aware of it. It should be like that only. Now, there is a syntax here. Did you observe here? Some dot SSX. What do you mean by that? So here you need to understand dot means so success are okay. Okay, so and like yes means skipped, and like so x means expected failure. So this is like nomenclature here. Hope you understood the test case. So totally there were 4 test cases. I skipped so 2 of them, and one of them is expected failure. Did you understood the result now? And I'm saying okay means whatever you wrote based upon that it is correct. It worked like that. Is it clear how the test cases are being tested?
Yeah, so why it is not coming addition is clear, right? So why it is not showing the as one more success for the.
First one it is showing success, right? Dot means success only.
Oh, okay.
That's the reason. So it is dot. So that's what four you got right there.
Okay, yeah.
So dot means success. Yes means
Dot means success. Oh, okay.
yeah. Second one skipped. The third one skipped. Fourth one expected failure.
Okay, got it. Thank you.
Fine. In the same fashion, you can also go with like something when you're doing like a timeout testing. Yeah. So testing timeout. Okay, till now you have a problem, so you are solving. But what if you have a timeouts or some kind of issues? That's where you can do. So, so sometimes people will write unit tests very smartly. So don't think like too much. Instead of unit testing dot testing, they do a selective import. Don't think it is crazy. If you feel so, like you can just take like this, import unit test. So unit test dot test case, and here also unit test dot main. If you want like verbosity, you can say like verbosity equal to true or so and so. If I say it will execute. Now what I'm trying to say here is very interesting. Till now you have test cases. You wrote many things. But for the test cases also we can write a decorator that there is something called as timeout decorator. If I use the timeout decorator, it will do the executions. And I mentioned like 5 seconds for 5 milliseconds. Okay. So what are the number you count? Anything generally it is milliseconds or 5 seconds. So this much time it should wait before that it is executed. Say if I say Python f so and so, it should go and execute that. What is saying? Hey, I don't have this module called as timeout decorator. Then you do. This is a module called as pip install -u like this for the current user. So until unless you are in a virtual environment, so use the __ user. So it executed. If I execute now, did you understand what happened? The signal was failed. So did you see it failed? Because you gave only 5 seconds limit for it. But it is looping for 10 times. Each time it is sleeping for one time. Means like if you use 1 millisecond each time means 10 milliseconds it will take. But you are waiting only for 5 milliseconds. So that's the reason it will fail. Excuse me. Yes.
Go eat.
Okay. So that is how it works. Next, going further, if I give like the same thing some 50 seconds, and if I execute again, it should execute further. What it is saying here? Attribute error means I think something broken here. Okay. In this module, something was broken. So it is nothing to do with us. This is a third party module, right? So we need to go to their module, whether they fixed this or not. Seems like they didn't fix it. So we should see about the alternative, something. So earlier I used to use this module a lot, decorators. So like that for different kinds of test cases we can have. Next, till now we have seen the basic things like different kinds of use cases. The real world, how you will face all the things I told. Now in real world, people will not do these kind of things. they will have some kind of test setup. For testing also there will be a setup. How this testing setup works means, generally we have one test, right? If I take like one test, say test case demo I'm taking. If I'm writing like test, we got to this notion of, right, test 01, say something you want to test. Okay, so I, instead of testing something, I will write like, so in this method called as test something, that's what I'll write. If I execute this one, say like unit test dot test test main, if I execute, so Python f so and so, if I execute, I got it. For you to better understand, I wrote this print statement so that you'll understand. And you saw it is a dot, means like there is nothing wrong. I didn't even write an assert statement. See, assert is also not mandatory, but it's not good to not have it. But you need to understand that there were two methods which you need to have, before and after. There is something called a setup. And similarly, there is one more thing called as a tear down. In a test life cycle, test case life cycle. Life cycle means it is born, right? When a test setup cycle is born, we will have this setup. Setup method is executed first, and like so all the things will do. So when it is so before death, so then like this tear down method will execute. So when a before and after, you see now, if I execute, you'll understand. Did you see for this test case, before and after it was executed? And it doesn't mean like for everything we cannot place like this, right? So I will just place it here so that you'll understand. Maybe, sir, I am taking one more test case. I have like test case 2. I can say like some other thing I have. I do like here. I have like third test case, and here also I have like a third test case. Okay, now we see in this example what will happen. What happened? There were three test cases, right? So these were like ordinary methods, and observe the syntax should be exactly same. If I say like a ordinary down, it will not work. You should give set and u capital and up, tear and u d capital and up and down, like that. And each time before executing and after executing, setup and tear down were executed 3 times physically, right? So this is what I want to prove. Hope it's clear what you understood. So before and after executing your script, your things will be there. So if any time, if you want something to be executed like that, you can go with this. This is all about the test life cycle. How a typical setup will be there and how things will work. So that's what I want to tell. Okay, if it's clear?
Yes.
Fine. After this, if I can go ahead, if I go with the next thing, if I have like a testing the test classes, test classes. So here, now I will tell you 2 more things extra. As you till now you understood some things, right? I will explain now. Every test case, there will be a setup first, then after the test case there will be a tear down. Again a setup, then there will be a tear down. Again a setup, tear down, a setup, tear down for each of the things. But for all the things at one shot, there will be one more thing called as a test suite. Means like, let me take the previous example. So I have this entire code, right? I will take the same test case. You see now, you have it. If I execute the same code again, I'll get the same answer again. If I execute Python H test cases, you see what will happen? There were 3 test cases. Every time setup will execute, then the first test case, tear down will execute. Again, setup will execute, second test case, teardown will execute. Fine. Now like this, I want to introduce two more things called as a setup class and a setup method. So in real time, they will not place top and bottom. Everything they'll place in the top only. So you need to understand. Did you understand the difference between setup class and a setup method? So this is an instance method, right? Whereas this is a class method. That's why you wrote a class method, right, in the top. And you wrote CLS and returns none like that. So you see here, what is the difference? And similarly, like tear down, there is one more thing called as tear down class. So for you to understand, maybe like I can write here only separately. So I'm just doing like this: setup class, tear down class, setup and tear down. Now, if I execute, you will understand it. So for you to better understand, let me give you like a this thing. You see here, slash n, slash n, and like here I will give like sorry slash t slash t slash t slash t, and here also slash t slash t. Now, if I execute, you'll understand more clearly. Did you understand now? The setup method is executing first, and tear down class is executing in the last. In between, for each of the test cases, both setup and tear down things were executing. Did you all understand? Yes, any doubt? Setup tear down class is one per this suite. This is called as a test suite. You should call it test suite. You should spell like test suite. So this is called as one test suite. Within the test suite, we will have multiple test cases. For each of the test cases, before and after the test setup and the teardown will execute. Overall, for the test suite, once in a while, so this one will execute. Hope it's clear. Any doubt?
No.
Okay, fine. So this is how it works. After that, if you have like multiple test suites, means like this, if I have like multiple test suites, how things will gonna work? Multiple test suites means like if I have some functions and I can do like multiple test suites. Say like this is one of the real examples which I want to do. Say like yeah, you see I have one function called as function test1. It is taking a name and I'm checking that Mona is there. Is it starting with MO? So you see assert, simple assert, right? I have a function and I want to test it. So how I'm doing here, if you can observe carefully, yeah, and clearly you can see there were two. Well, this is an ordinary function. This is also an ordinary function, and I'm doing a test case for it. Unit test case 1, unit test case 2, something I wrote. So this one I want to test like a foo, some ordinary things I have, and this also like I have a test case, another test suite. So this is another function I am testing. Test bar I'm saying test so and so. So I have like this. Generally, this kind of test we will do when you go for PyTest. I will tell you shortly afterwards. But this is an ordinary function which is just comparing, and these two are the test suites. So totally 4 are there. If you have like more than one test suite, and if you want to do, you see here, you are taking the test suite. So generally, you don't do this in real time most of the time. But sometimes, if you want to create your own test framework, that's where people use it. So you create a test suite, and for that, every time you add all the test suites, individual test suites, and you can give some kind of naming to this test suite also, and naming prefixes, all these things you can do, and you can add. See, these two are a test suite classes. This is a test class, right? Test suite. And similarly, this is a class, test suite. You wrote both the things, but fine. Similarly, you have one functional test. So you have one function test, right? Which is giving a result. That also we can add. That's why it is called as function test case. So till now you are using only class-based test cases, right? Class method, class in that instance method test case. So here it's a function, typical assert. I cannot do a self.assert equal to, because here it doesn't work. So either of the things it will work, and it will take, and it will return the suite. So now we created one suite, right? That suite you can do, take the suite and like unit test runner, and for that runner you're adding the suite. Whenever you have like multiple things, and if you want to execute together like an individual entity, you can go with this. It can help you. It's clear? So it is saying like 4 test cases were executed. So a lot of things came. Means like it is saying like some of the things were deprecated. So unit test.make test suite is removed. So in like latest version. So and like it is being replaced by test loader dot load test case, it is saying. Means sometimes things will go deprecated also. So we need to, I will try to upgrade it. Recently many things are coming like this. I hope it's clear till now. You understood how to write a test case, what is the purpose of a test case, but you are not going for a real example, right? So one example like you are not doing, and you are not checking the things. But if you want to do like that, that's where like the other things comes. You till now understood like individual test cases. Let's say like this. See here, everything is like a test case. Everything like a test case means code is also there, test is also there. But in real time, you will not push this code to the production, because in your production code there should not be anything like this. Then in that case, what should we do? So in that case, I would say like we have B example. If I take this, you will understand that in the B example, I want to take a small example. Say like I want to take a small script. In that script, I want to write. Okay, so my action is like a script.py I want to create. See, this is a folder I have. Within that folder, I want to create something, and I want to work on it. So how I do, I will show you. If I go here, and I wrote one script like this. So it is an add one. If you're giving anything, for that it will add one value and give it. Hope you see I wrote a doc test also for you, such that you can get familiar. So there is one script now. For this script, I need to write a test script. For any time when you're writing a test script, so the best practice is like this. What are the script name is there? We need to write with the same name, but it should either start or end with a test. So generally, most people will go with the test underscore script.py, but you can go with like script underscore test.py also. So what are the file name you have? Prepend it with a test underscore. That is the general notion that people will go. So and like if you want to test this functionality, which is there here, right? If you want to test it, so then how do you test? First, you take like the unit test, and like you need to import that. How do you import? As it is in the current directory, I can directly do from script import add one. From the script function, I have add one, right? I'm directly importing. I get it. So after that, I need to work on it. So so generally, if I want to take one of the values and test, say add one, just I want to check whether it is working or not. If I see ls, you got the values. So you have only 2 scripts. If I say till now script.py, till now what you are doing, you are going to the script. In the down only, you are writing a unit test.main. But in real time, the people don't do like that. Then how to test, sir? You go to the Python. So test a script right now and execute. If I say like, I'm executing the test script right now, it will work. Now, so if I want to write like test, say like, I need not write everything like this. My test suite. I told right, it need not start with a T test. but like it is best practice actually. Unit test dot test case if I write, and within that if I say define, say instead of test I am saying like testing 01. Can I do like this? I'm just giving a different kinds of thoughts, checks I want to see. So for doing this, if you see here, if I say test one equivalence, so I'm checking like result and that should be equal. So result and that should be equal. Yes, if I add like 1 to -3, it will be -2, right? So similarly, I want to check other kinds of tests also. I can do. I can add all the test cases, and here also, if name is equal to, if this is the case, I want to do like unit test dot so main, and I can last like verbose equal to true. If I do, now I can understand that Python test script, if I execute, it will work. So now, did you see that you segregated your main code and this one separately, and you are not doing anything, right? So like this, you created one separate script and you did it. So similarly, so let's take one more example. Yeah. So let me take my one more example. Say like this time I'm taking one more folder. Maybe like if it is big enough, I can open that itself. If you feel this is humongous, I can open this particular folder, open folder, and so and so. You can focus only on these unit tests. Things will be easy for you. Yeah. You see now, so after that, if I create a new folder, see example. So within this, if I want to create one file called as say like person.py, I created a Python script. Within that, I want to create a class and I want to add some definition. See, I wrote some doc strings also for you to better understand doc testing. So add a unit test. So sorry, constructor. Self.name is equal to empty list. For that, I'm doing a set name. If you give any value, it is trying to append to it. So and it will return the length of this thing -1 means total values length, and get name means it is doing some logic, it is doing, and I want to test it. So how do I test it? So for that I need to write this same file, right? Test underscore, and with the same name I need to write. So it is not mandatory to do write that, but it is a best practice again. So individually you can go to these test files and also execute, and directly also you can execute. And if I say like how do I do from this particular program, I need to import it. That's the reason, see, class name should start with a capital, right? So I am just inheriting it from person, import person, and I did the unit testing also. Now I need to do the test for this person. I want to check what is the point. Every time you first you create a person, for that person you do a set name, get name, and all these things, right? But first you need to create a person. So how to do that? So let's go with this example. If I need to implement, say like I want to test the functionality. So testing functionality means what? So first I need to create that particular thing. Say like this person, right? P is equal to person. Person of say, so person I created. Same like in the previous statement. And for that I want to do like person dot set name of something I want to check. Set name of any name. I want to check whether the result are same or not. Say like I wrote one use case like this. You see? So P is like this. I have. You see in this example, you can understand. You're taking P is equal to this thing, and I'm taking a test name like Prakash, and I'm setting a value. And after that, I'm saying I'm retrieving the value. What are the set? I did a set. The same thing will be there, right? And I'm retrieving also. I'm checking the values, whether both are equal or not. This is also one way of testing. And similarly, if you have like one more test, say like I have multiple people, I want to do a test. Say like yeah. So I have one more test. So for this also I can do the same thing. You can see here. So whenever like I'm getting it, I can do this test. So what I'm trying to say, this time I'm taking these many people. For all these people, I am doing the same test. So here I did for a single person. I am doing for a list of names. But in both the cases, did you see p equal to person is coming common? That's the reason for common things that everyone needs. So we need to write. So this common thing is needed for every test case, right? So that's the reason you write in a test setup. And subsequently, instead of doing directly, you can remove that and you can do a self.p. And similarly here also self.p is equal to. So if you do like this, then you need not reuse. So you can better reuse, right? Sorry. Self.p and here also self.p. Hope you're understanding what I'm trying to say. As this person creation is needed in both the functionalities, instead of writing in each of them, you write in this setup. So like that, whenever you have something common, you can go with it. Similarly, I can have written like one more test case. So means like again I'm taking few other people, and this time each time I'm checking it. See, individually this is one case. This is very interesting. I have gone for these many people. For each of the person I am testing here equal to, means each result I am checking individually. Rather, if I want to check holistically all the results together, I can do another thing called as list assert list equal. Means what are the end results list is there after doing all the things. Then I'm checking with this end values. So it is much better than this individual checking. Of course, each one has its own pros and cons. Whenever you want to check specifically, you can go. Similarly, if I add like one more unit test and I'm doing the complete test. And here in the verbosity, there is something interesting. If I go for the unit test main, so they will mentioning like, so verbosity levels that you want to do. If I specify the verbosity levels, I can check with respect to that. How much level of verbosity I want, like that I can check. So in this case, you see here, so test setup is needed. Teardown is not mandatory. Means teardown is something where you want to delete this thing. But in this particular case, I don't want. Even if I don't implement also, it doesn't matter. And also the setup and teardown are not mandatory. If in your logic, if you need, you use it. Say like if I'm taking some mutable object like a list, for each test case I want to update to that. In that case I can so clear that cache or do something. That is the way. Let's say you are opening a file. In the teardown you can do a closing that file. So like that things you can do in a teardown. But in this particular case, teardown is not mandatory. Anyhow, if you don't do also, the instance will get deleted. But if you want to specifically also, you can write. So like that you have. And if you want to execute it, the same thing, you need to navigate there and execute it. So ls, if I say, I need to navigate to the third example, Python. So after navigating, I should go here. So I got to the file, Python. So instead of person, means main logic we are not touching. I wrote like the test case separately and I'm executing. So there were like 4 test cases. 4 test cases were executed. Everything is successful. So this one we understood. In the same fashion, let's go for the last example before actually going to the real-time things. Means this time I will write like this. So multiple test scripts. So if I go with this example of a multiple test scripts, how I do? Let's see. If I take till now, what are I'm having? I'm having only one code, right? So one script .py file. So I have some logic. Maybe like here I'm doing a logic called as anagram. Means like if I take two strings, I want to compare both are equal or not in terms of the characters. Means if I say cat and act, so both are equal. Means so in terms of the number of characters, if you see, So C is there, C is there, A is there, A is there, T is there, T is there. I want to check both of them. So how to check both of them? I can just take it directly and execute it. So how I did, I sorted the first word and sorted the second word, and I'm comparing both the results. So this is how I wrote some logic. This is my test case. So sorry, my main code, and I want to test it. Instead of writing anything here, so you see, I will write one separate script. So for writing, say first I want to test. Till now you are writing one py file, one test script, right? This time I write one test script, first test script. I write whatever I want. Say I want to do some testing. So means like first I need to inherit, as it is in the current directory only. What I can do, from my mod import. So in the my mod file we have like is anagram. I can say import is anagram, and like import unit test. Import unit test. So you got both of them. Then we can write the test case. Test anagram. What are the tests I want to do? I want to do a positive testing. I want to do a negative testing. Positive means like I give two values. I want to say both are equal, both are equal, both are equal. At the same time here, assert false I'm saying. So if you do like 1 and 2, they were not equal, right? So 1 is there, O is there, O is there. N is not there in both. So then it is not equal. So if I want to execute this particular logic, so I need to go here. I need to go to the D. So Python. I need to execute the test script, right? If I execute, of course, test script will execute. So fine, there were two test cases. How many asserts it has, it doesn't matter. Total test cases, it will check. Now I will write like one more test case. So instead of writing the test suite within this script, I want to write like multiple script, another script. So this time also I want to test, but this time I have some other logics to do. I write like this. Again I imported, and this time I wrote it. So this is also test anagram. This is also test anagram. So two test anagrams are there. You see. So here test anagram positive, test anagram negative I wrote. Here just test anagram, test multiple words like that I wrote. Now we see here, if I want to execute, sorry, if I want to execute, if you see the tree, sorry, if you see like ls list of files in this directory, if you ignore this one, because anyhow when you import this will come, right? We can ignore it. You have one main program, two test files. How to execute? You cannot execute them. If you want to execute the main code, you can execute your script as it is. But the test scripts, if you want to execute, individually you need to execute. Because you wrote this one inside, when you're executing the script, it is executing. Similarly, if I execute the second one, if I say test2, that also will execute. I think somewhere I created a nonsense. So line 15 it is saying. Yeah, it executed. I repeat again. Python test so and so. Python, it executes. Both are executed. But if you want to execute like this, you need to individually specify what all you want to execute. What if there are 10 test cases? You can't execute everyone, right? You cannot place everything. Sir, why you want to write everything? Why can't you write everything in one file? Just imagine when things are becoming big. So you don't want to write everything in a single file. So that's the reason. So we need to have a different strategy. Now we need to learn something very interesting. So this is how in real time people work. If you want to individually test any script, you write Python space the file name. But ensure that within the code there is a unit test.testmod. But if you want to check and you want to execute all of them at one shot, then you need to use a module like this, python-m unit test. Python-m unit test. If I do like this, it will discover what all the unit tests are there in the current directory and below, and it will execute. Did you see what happened here? Ran 4 unit tests. And if you want like -v, if I say you are doing a verbose, so did you see that? So whichever the test case is starting with test or test underscore, whichever is, it is proactively doing it. So in the first test case script, so what are the test anagram, test positive is there? See from which one it has taken test mod, test mod. In test mod, two things, test mod 2, two things are there, all of them executed. So that is what you need to understand. From now onwards, you do like this. And one more thing, so multiple test cases, how to execute, I told you. Now the next one is about code coverage. Code coverage means, okay, you wrote the code and you are writing the test cases. Assume that like you did four tasks, like say getting a file from somewhere, so you're doing some transformations and dumping to database. So 3 actions are there. What if you are testing only 2 actions and the third test action you are not testing? So then like your code is not reliable, right? Means whatever the code you wrote, completely it should be tested. Of course, in this case, there is a very simple thing. In the subsequently, you will see much better things. But if you want to see the code coverage, this is how you do. If I say code coverage, I need to run anything. So you know what you do. So I told like Python -m unit test, right? Python -m unit test. This is how you execute it. Now, before that, you write like this thing, coverage. Coverage run -m unit test. So coverage is a built-in module which will help you. So it is also executing like this. But what is the difference, sir? Means it is created a new file. Did you see dot coverage? If you open, you cannot understand it. Even if I say like in a text editor, you can understand that something is coming so clumsy, but you cannot understand it because it is a report. So from that, if you want to the coverage report, coverage, if I say a report, I get the coverage report. What it is saying? Hey, you have the my.py file. This is your code. In that, how many statements are there? So 3. How many missings are there? So how many statements is saying? 3 statements is saying. So it is taking this entirely as a one statement. So another statement and a third statement like this. So 3 statements are there. How much code coverage is missing? 0. 100% code coverage is there. And similarly, in the test mod file also, it is saying in the test mod file, there were 12 lines. But like, so one of the line is having a missing. Code coverage is not there for one line, it is saying. And similarly here also, everything, so totally 11 lines are there, but one of the things were missing. So okay, 2 misses are there. Totally 92% code coverage is there overall in this folder. Then like we need to understand which is that file value which is don't have it. So generally we cannot understand that here, right? If you want that, it will create a coverage HTML. If I do, it will create a HTML file. So this HTML file we need to open in the browser. If you open in the browser, you can understand this HTML file. If I open like index.so-and-so, did you see? It is showing like this. Again, the same report it is showing. Then how can you understand better? So to understand better, if I say here, you see now, individually now I can go. I can check. If I see here, if I hold on something, I can go. If I say, so test underscore so-and-so, it will show. It is saying that these below lines are, so not having a test coverage. To be frank, it makes no sense to have them, right? But you understood now. So if I go to the next one, that is also saying the same thing. So if I go to each of the file, like in the main file, so no thing, right? It told like there are 3 statements, means how? This is the first statement, second statement, third statement. That's how it recognized the statements as. These are all comments, just ignore it. So sorry, docstring only. So but like you understood how the coverage report will come. So going further, hope you understood now a real example of how the code coverage and test coverage will happen. So now going for the real practical examples, let me take this time a consolidated example of multiple test cases, multiple things. Let's take a, say, calculator example. Okay. I want to take a calculator. So this time I want to say like calculator .py. Okay. So calculator means what? It will do like addition, subtraction, multiplication, division, right? So I want to take 4 functions. So addition, it will take 2 numbers and return the float, convert to float and addition result. Subtraction, multiplication, division, 4 things are there. Now for these 4 things, I want to do the test cases. See here, earlier what I did, I have one file, 2 test scripts I wrote, starting with test underscore. That's why it recognized those files and it has gone there. And similarly now, what I will do, instead of doing like this, alternatively, you can also do one thing. You can create a test folder. I'm creating a folder, and within that, I want to write the test cases. So within that, like say, I want to write like a test edition.py. If I do, so you see here, instead of writing in the same directory, I'm doing like this. So what is the advantage? You can have multiple test folders, but all the tests will be placed in the one place. So if I have like a test multiplication now, I can place that also here. I can have test multiplication here. And similarly, I have like test subtraction. I can place that also here. I have like 4 test cases. Now, when the user is focusing, they can see the real code. So the test cases are also part of the code, but they are not the main logic, right? So test cases will be separate now. So that's why in real time production, they write it separately. Okay, let's implement this code and how would you write it? Let's see. I need to till now what is happening. Everything is in the same directory. You are able to do it. Now we are not in the same directory. We are one level different, right? So now let me try to import that. So how I do, let me show you. If you see, import unit test, I do. Import unit test. This is fine. But how do you import this calculator? In that I want to get the addition. This is what I want. How do you address it? Say, can I do like from calculator import addition? Can I do like this? Let me check. So what is the present working directory I am? If I say ls, I am somewhere in middle, I guess. I need to go back. Yeah. Calculator I have gone. If I say ls, you can understand. If I say tree, so you can understand. Under this it has tree, and within that it has. So I, instead of checking with all of them individually, I want to check like this: Python -m unit test. This is what the only strategy I have. But still I am trying to import it and do it. Say how it works. Let's see. You are not in the same directory, but you are somewhere in middle. So then will it execute directly? It means it depends upon where you exactly execute. So if I go to this directory called as tests, and if I execute individual script like Python test edition, what is saying? No module named calculator. But like if I execute from outside, so here, if I go outside, from outside also you can execute, right? X slash, so test edition, test slash test edition. Like this also you can execute. In both the cases you are checking, it is saying that I don't know what is calculator. But you are, if you're executing like Python -m unit test, it is executing, but it is fine. Means when you are doing unit test, it is doing at the module level. It can understand what is it. But individually when you're doing, it is not working. Then how to handle this case? When you are doing this, that also I told. Means like you are in a subdirectory. You want to get to one level above values also into it. That's what, right? So how do you see? So can I do like this now? From previous directory. So means from the above directory also I want. So can I do like, s dot so and so? Means I want to go to the above level and ask. It is saying like I don't know what is test also. Means you are in a directory. So for that you don't know what is the above level. How do you, if you remember, about the sys module, I told you one thing. Import sys. If you print like sys dot path, if you remember, I told you here clearly. If I execute like Python space test edition, so like if I go into it, Python space test edition, if I say, did you see how many paths you have? Maybe like if you want, I can print it for each path. Sys dot path. Sys dot path is the list of each of the paths. If I say each path, you can notice how things are working. Did you see what happened? So these were all the paths. Whenever you are trying to import something, it will check in all these directories. So did you see that it is checking the test folder? As this calculator example is not in the test folder, it should go in the one level above and check, right? But that is not there. So that's why it will throw an error. Rather, for this module, I will add one more thing. Generally, if you want to add any path, so there are two ways. Either you need to go to the Python path, which is something complicated for you at this stage, or simply you can say python.path. It's a list. Either you can append at the last or insert in the starting. So I want to insert in the starting, means I want to prefer that. So what I want to add, so I want to add one more path. The previous directory also I want to add. Now, if I execute right now, did you see this previous path is also added? Then what is the point, sir? It will check first in the previous directory also. Means the one level above it is means what here only, right? Now, after this, if I ask, it should execute. Oh, it is still throwing the error. This is the most problem everyone faces in real world. So everyone will does this insert, but we should ensure that your import should be done after that. Generally, most people will do this mistake. So that's why I'm telling this individually. I too did this mistake a lot of times. This one should be done import after this statement. Only after inserting only you should do this. If you do this above, it will not work. Okay, now you understood the importance of this sys.path.insert. So now if I do, it should not throw any error to me. If I execute, it's working perfectly. Did you see it created a PyCache? Means like everything worked. Now it's a simple logic, like how I want to insert and how I want to do the additions and this. So here, if I take a test case, I wrote like test suite addition, so unit test suite. So test one, test two, test three, I have. Test four I added, but I want to make like expected failure. But did you see I didn't write like unit test main? Because that is not needed, right? Earlier also you see code coverage came. Because that should not be there in the real code. I removed it. So this is how professionally we write. So I wrote like positive, negative test cases, something. You can just walk through it. Similarly, if I go to the division, the same thing works here also. What are we have learned there? The same thing works here. So here also, unit test edition, we are doing an insert. You see what I told. First you need to do the insert, then we need to import. So then if I do like this, it will do like this, it is working perfectly. So four things are there, 1, 2, 3, 4, 4 are executing. And in the same fashion, I have like one more function for like multiplication, one more class, script. Multiplication also 4 test cases. The fourth one here also I mentioned as a should not work. It's like expected failure. Similarly for subtraction also I wrote 4 things, expected failure for the last one. I wrote something like this. Now, if I want to execute these things, how to execute? From now onwards, I'll write, if possible, like, one explanation script so that you can walk through that, the statements. So there is like, if you want to test all of them, if you just do unit test, so it will test anything. So it will just test for a folder called a test by default. If you have any other folder name apart from tests, where your test scripts are all present, instead of test, if I say like my test, then you should explicitly give. In other cases, it will only do automatically discovering. If you see in the current statement, if I say list of files, I am within this folder called as tests. I should go one level above, right? Here I can individually ask for any test. If I say Python -m unit test, unit test times t should come, right? That is one thing. You see, it executed. So it is saying like how many are 16 executions. Did you see here every dot makes a difference? Dot means everything successful. X means expected failure. So for each of them, I added 4 tests each, right? 4 4 is 16. In each of them, fourth test is like expected failure. That's why you got it. And if I go like one level above, here also I can ask like unit test. It is saying that one level above, if I ask, it is not executing. See here. So if I go here, one level inside tests, if I have all files, and if I say like Python -m unit test, if I do in the current directory, what are all the files which are there, which are starting with a test, it will execute. But if I go one level above, means to this level, if you see the list of files, I have my calculator, explanation, and test folder. There is no file with starting with the test, right? So it will not automatically execute. Then in that case, we should specify these things. So if I execute right now, it will execute. You are telling that, hey, go to a folder called as tests. There you have all my unit tests together. In that you execute. Then it will go to that folder and check for any file with the again test underscore, and it will execute all of them. So it should execute them. I don't know why it was stuck. Don't know why it was struck. So any doubts still now?
So,
Yes.
yeah.
Please.
So, we are doing the like all the test, right? Using the M unit test, by whatever the directory, how many unit test is there. So, how we can identify from that there is a 4 failure on this particular test?
You can do a verbose.
Verbose. Okay, got it.
Verbose. Verbose
Okay.
is the way.
Okay, got
I
it.
think it was struck. Let me close and open again. You're somewhere here. You need to go to the example, right? The calculator, ls. I have the files. So I can go Python -m unit test discover test. Yeah, I wrote like test. That's a difference. If I write, so test, if I write, I got it right. The exact folder name I gave, it worked. So what is this coverage actually doing means it will execute what are the statement we have. For us right now, the statement to execute is this one, right? Just instead of writing our code, so we will write prepend this coverage file. That's it. Coverage means it will execute our code. When it is executing, it will do the job. So what is our code? Unit test discover test. So unit test discover test, if I wrote, now it will execute the same thing and result it will store. The same like your test it is executing, right? I think like from now you need not execute unit test. If you execute coverage, indirectly it will execute unit test, right? So here also you got the coverage. So again, if you open the coverage, you cannot understand the code. So what is the way? I told the 3 coverage statements. Coverage. So coverage run means the main command to execute. So similarly, coverage report, and like coverage HTML. If I say coverage HTML, it will write to a folder called as HTML-con. If I navigate to this directory and like open this file, so there will be index file. So if I open that, you can notice it. You see now? So it has 100% coverage and you have these many files. Did you see? Now you go to any of the file, you can notice that calculator, how many values are there, totally how many statements, how many ran, so how many skipped. So everything you can get. So if I go to this one, it is showing like what are the cases are there, what are the word is there, what is the coverage report when it was created. So like this, it will give for every program. So now don't you understand that in real time it works like this? So after this calculator example, any doubt before going further? Okay, the last two examples I will take with this and do it. Okay, let me take like a calculator again. This time a small another calculator. Say like EF calculator. So this is a typical traditional application which I want to do. Mm, yeah. So I want to use the word called as calculate. Calculate.py. Okay, calculate instead of calculator. Calculate. I have. So I want to add something. You see now. So I till now didn't tell like there is a underscore underscore file I told. These are like metadata. Similarly, there is one more thing called as underscore underscore author underscore underscore. For every Python script, you can also add like who is the author of the script. If you remember in earlier, so when Git is not that way, people used to write their names, who or as has worked on this program, so that easily to understand. So and like who is the latest author, they used to write here separately. To understand that as a meta information, they placed it. But nowadays Git and everything people are using morely, so that's why this is no more used. So but like still this metadata is there, just for you to be aware. I'm just telling that. Fine. So I created a class called as calculate, and it will do two things. So within one class, I have two actions. Earlier, I have functions, right? This time I have a class which have only two methods, and I want to add it. And I want to write a unit test, the test underscore calculate. Same name, whatever I have, I wrote it. And similarly, I want to execute this test. So for this test, here the point is what? How you are executing this logic? First, you are creating a calculator, and for that calculator, you want to do everything, right? Yes or no? So it means like, so you need to create a test suite which contains all this information. So how I do? Let's say if I create a unit test, so class test calculate, right? Calculate. And so we need to do unit test dot test case. If I have here, so as you know in the previous case, first we need to create a calculator, then we need to do. As for all the test cases, one time we need to do, will do a test setup class. Earlier, you remember setup I did, where every time I want to create an instance I want to do. But here, you calculator, you create one time and you do different operations separately. That's the reason I placed like. Due to that, what happens? Every time if I execute, whatever I execute, I can do like this. Test addition, multiplication, like that I have. And here, order doesn't matter for me. Whenever order is not matter, you need not write like numbering. But so if order is matter, that's where you read. Let's say you have a database connection. First, you need to connect to database. So create the records. Then you want to check the records, whether they are present or not. Then you want to update. If you have that kind of sequence of steps, you can write like test 01, test 02, like that. If you don't have like that, you can write individually. So as like everything is done, and after your action was done, you can close it. So see there, down class. And it also is a class method. That's what you need to understand. So I now wrote like two things right now. And how do you test? See here again, Python -m unit test. I think I need to navigate to this directory. Calculator. I got these two files. It is like a ordinary execution. Right? If I execute the calculate program, main program, it will execute the main program. If I execute the test script, now test script will not execute directly anymore because you are not writing this condition, right? So how do you execute? Python -m unit test. For that, if you can pass a script also, but indirectly you can understand and do. So now I know even that coverage is there. Coverage run. So the same thing. So coverage run. Any script if you have. So here in this case you have like unit test. If I say it is executing, no file to run. Yes, it executed. It is saying two files executed, and it created the coverage. And if you want coverage report, it gave the coverage report where it is saying like, so there were 7 statements, 0 misses. So in the calculator 2 also 14 statements, 0 misses. That's what right you expect. So if you want coverage, you can ask like coverage HTML. If I do coverage HTML, it will create a HTML file. You can check the result also. Fine. This is how the real world coverage statements and all these things will execute. Hope it's clear till now. And the last thing that I want to show before winding up today is that, say one more example, EFG score example. This time, say I have one online shopping cart. Online shopping, I have some logic. I am taking right 2 classes. So see here, there is one class which is having constructor of 2 attributes. It's taking 2 values. And the second one is another class which is taking no attribute. When each time when you're doing a shopping, it will add the values and the prices something. For this thing, I want to do a testing. See, I was given this test. Initially, when you join as a beginner, you will be given the ready-made code, which was already there, and they ask you to write the unit test. So if you want to do now, how to do the test? You don't know anything about this code, brand new it came. First, you need to understand what is this code doing, and we need to action. So you can see that there is a one class called as an item. If you give it, it will store. Means it will store item with 2 values. One is the item and the price. It has 2 attributes. And these two are not related at all. It's not a parent child. Both are separate. And here in the shopping cart, so whenever you are doing an item add, each time it is adding an item. Means this class instance it is taking and adding here. So like that every time. When you're asking the items, it will get. So how do you test this functionality? So this is a very good example, right, for me now. So how do you test it? So for this testing, I can start with. So this testing this online shopping means what are the file name I have to take it. I need to do like test. So I need to go in this directory only. See here, highlight where you want to do test underscore like this. If I do in this directory, it created. After going in it, the simple things we need to do is like import unit testing from online shopping. You want to import the shopping cart. So similarly, you want that item also, right? So you have 2 things right now. Item is also there, which you want. If you want to individually test item also, and if you don't want to test item, you want only shopping cart, that's fine. Now we need to have like 2 tests. So first thing, as it is simple, I will do the first one, item test. Item means if you create an object, it should take 2 values. I need to check for both are present or not. How do I test it? Class test item. That's what, right? Unit test dot test case. If I do now, what I can do? I think I don't need individually for everything, right? No setup, no takedown is needed in this case. So I can test like test, say, positive item creation. You want to test that. This is what I want to do, right? How do I test this item I have? So for the item, if I pass 2 values, it will take an example and it will give a result, right? So now, if I take like one example, like say price and two things. What are the two things it has taken? It is taking like item and price, two values. So item should be like integer, should be like a price, should be like a this one, right? So or like what or maybe item should be like some string I'm expecting. So we don't have any information. That's the reason they ask you to have more documentation. Assuming that item is some string, so price is some value in floating point value. So I can say like bag I brought, which is of cost like 45 pounds. So I created like this. So whether able to create or not. Now first write a test case of what you want to test. So want like so valid creation. Okay. So check all data types. All data types you want to check, and also like what you want to check. Look for exceptions. Means when the code will break. So look for exception handling. Means code breakage. Whether code was broken or not will be potential. Maybe I will give as an assignment for you. You do this for in the home and come back tomorrow. So we will work on it only. So like that. So how to handle exceptions? All these things in the assets we have, you need to think of how to do. Okay.